能不能开始？
我们先简单说。
Oh, hello.
Hello, everyone.
1 second.
有17个人。
好。
Hi, hello, everyone. Welcome to our stream. So we'll be start really soon, and we are the member in NestWorks. So today we're gonna show our very latest product. It's called NestWorks C500. It's a desktop level CNC milling machine. So at the very beginning, we're gonna have a really brief demonstration for our product.
Okay. So hello everyone. This is Henry from NestWorks, and also I'm the one who's interacting in social media and also in our user groups. I want to thank you everyone for following our projects and attending our lives today. Jackie is our software product manager. So he's the one who's working behind the CAM softwares and doing a lot of amazing functions like automatic two-pass generation. So we are very honored to meeting with our users today. Because during the past 2 weeks, we have heard a lot of questions and interest about our product, our team, about the people want to see what's the real performance and what's the story behind this amazing machine. So we think this live provides us a very good opportunity to have some communication conduct face-to-face. So if you have any questions, please feel free to leave us a message and send us a comment. I can see this through my phone. I'm watching all your comments here.
Yeah, just type in the chat.
Right. So I will. I might stop and just answer some of the questions you just sent. Okay. All right.
I believe that people will really want to know our NestWorks team and the Elephant Robotic and how we can create this NestWorks brand. Can you tell us, Henry?
Yes, we'll definitely go through that concept. So I would briefly introduce the live processing today. So first, before we get into some boring talking and communication parts, we will show the machine first. Let's take a look of the machine. We'll do a very quick 3 to 5 minutes demonstration, and then we will get back to the team story. A lot of people have been asking, and we'll have also post a letter about our background and the story why we were making this machine. And then we will have a Q&A section because we have already collected some of the questions from our users. And also, you can ask any question during the live right now, and we will answer as much as possible. And then after those two parts, we will conduct a processing just in front of camera in live. They will took about 30 to 40 minutes. We were making a stainless can opener in front of the camera. But because we will be open the cases, doing the processing, so one changes, we will take off the coolants. So there will be no coolants, but we're still working with stainless, so it might be a little bit slower than it used to be. Other than that, we're showing everything in front of camera, no editing, no pause. Okay?
Sure.
All right. So maybe give us a minute or two. So we will go to the demonstration part. So we can take a first look of the machine, and we will show some most fundamental functions. Okay.
I see some people already typing in the chat.
I can't really see the chat, Fei. I can't really read the chat. Can you help me? No, maybe enlarge it for a little bit. I really want to see what's talking about us. Sorry, guys. 1 second.
Some chats say, when is the Kickstarter?
When is the Kickstarter? Okay. So we have not decided the final date yet, but it will be on early November, either the first or the second weeks of November. Yes. Ability to cut nickel alloy. Yes, we were able to cut very hard alloys, including stainless and titanium. We were working on a titanium video today. I think we'll finish the processing. Yeah, so we will post another titanium processing video by this week. Okay.
Well, we'll also post those videos on our official website.
Right. We'll post on our website on YouTube. Just follow our channel, and we'll keep you updated. Maybe you can give the screen closer so I can read it. Yeah. Thank you very much.
Oh, shaking. It's okay.
Okay, I can see it. If it's guaranteed that I will get discount. Yes, if you pay for the VIP, if you pay for the deposit today, you're guaranteed to lock in the $25.99 price, right? And also will be in the first delivery. The other stream have a lot of folks waiting. Yeah, we will turn off the other stream. Okay, please check this. Right, Random's Kickstarter. Watchmaker. Hello.
Can you hear me?
Small item like wheels, steam, maybe case. Yeah, definitely. And yeah, we're definitely sending to Europe. We were conducting a very interesting product that I cannot tell you what it is, but we were working with a very famous YouTuber right now. It will be a very small, but also very, very complicated pieces. It's a small case, just like you have been mentioned. That video will be posted. I think we will try to get it delivered within a month, but it's also very challenging for us. Our entire team is working close with Strange Parts channel. So please waiting for our projects.
People asking, do we need an air compressor?
Yes. So the machine is we support external air compressor. So when you are using coolant, when you are using high pressure air for the table cleaning, then you will need an air compressor. But even not without an air compressor, you are able to conduct most of the work. Like because we have two built-in fan, the fan will help do air cooling and also will do the table cleaning. So if you have no air compressor, you can also have 80% of the task done. But if you have air compressor, fabulous. You can connect to your own compressor, and then so you can use the coolants to do the mist coolant. Yeah.
I'm just quickly show some of our
right
stuff.
Yep.
This is made by aluminum.
This a
oh no, this is made by a titanium, I guess.
Aluminum. This is a stainless.
Oh, okay.
It's a stainless can opener with our logo. Very strong. Maybe you can show closer to the camera.
This one is made by wood. It's a Christmas tree template.
Is it possible to find out what is covered under warranty? Yes. Sorry that we have not posted official warranty policy yet because we were now doing the final tuning. But we can introduce for the first time that we will provide a 12 months warranty, including the overall machine and key components. But even if after 12 months, we still have technical supports for some replaceable parts and self-editing, self-repairing manual supported. Yeah. Is there any estimated on when the machine will be delivered, or is it too soon to estimate that? Yes, the manufacturing is a very big problem. It's not easy for a machine, 200-pound machine like this. The current update is we were now in the middle phase of our factory building. We were building our own factory. It's actually going on right now. So we cannot provide a very accurate delivery date, but our schedule is aimed to deliver the first patch by the end of May 2026. So if you place a deposit today, we were looking forward to deliver our VIP user by next June. And for the later Kickstarter supporters, backers, we will deliver all users no later than August. So it's about 6 months because the Kickstarter campaign ends December. I know it takes a bit long compared with other consumer products, but for a 200-pound CNC, I think they're still in a very fast speed. So we will definitely keep everyone updated on the manufacturing schedule and processes.
I saw Oscar was asking about will there be a demo of our software?
Yes, we were actually conducting a demo of software today, just in this live. Maybe after the FAQ, after the question. So it will be maybe, I don't know, 40 hours from now, 40 minutes from now. Just please wait for that. What type of operating system is the CNC running? And we are running on standard G code, so you can either use our own CAM software, or we also support third-party CAM software like Fusion, like Mastercam, like SolidCam. So you can have your G code edited and finished in any third party, although we strongly recommend using ours. But you can definitely use any third party CAM software to generate your G code and send your G code to our machine by wireless way or with a USB. They will both work. And then this machine will check your grammar and then we will start to run.
Even though we are not compatible right now, but we will provide our machine parameters and also the post-processing file that you can input in your software and then generate a G code that can be analyzed by our machine.
Yes, yes. Mm-hmm.
So just let us know that what software are you currently using on?
What is included in the pre-purchase $25.99? So it will including one machine, 1-2 package. So they were including 5 most fundamental tools that we've been using the end mill in the 2 box, and also it will include a material box. We will provide you the material for the first starter, wood, plastic, and aluminum, I think, copper. Yes. So we'll have some basic raw materials provided. Yes. But other than that, our force axis and our electrical vise, the MGP manual generates posts, those will be all optional accessories. For the shipping costs, shipping costs and tariff, people ask a lot, but that's the tricky part that we also want to discuss with everybody. So first, talk about tariff. Tariff is something that is really not in our control because you all know it's actually the policy has been changing every week. They will not be the same. So we will keep the tariff information in track. Because the delivery is not taking place until May 2026, so we will definitely keep in track of the information and let everybody know. Our initial goal is to take responsibility for the most part of the tariff if they were still in the current situation. But if the tariff become ridiculously high, or the transportation have new regulations, and then we will try to figure out a new way, and we will keep posting with our users. So maybe in some case we will share the loads on the tariff if, for example, if they're charging 100%, right? That's a part. And for the shipping cost, it varies a lot in different countries. So what we will do is we will provide a very clear shipping cost table before the Kickstarter taking place. That they will explain the cost for a different area. Right now, our estimation, the highest shipping cost could goes to about $400 for 1 unit in some area, and then the lowest could be about 150. So I've been also convincing my team that we will try to take as much as possible from our sites. Right now, our estimation is maybe NestWorks team will cover $200 to $250, and for the amount that is higher than that, we might need our user to help us take some of that. So that's our plans right now. Not the final words yet. So please let us know how do you think about that. I think that's a fair price on logistic. Keep in mind, it's a 200-pound machine. Is really heavy. But still, we will still study more into the specific area and the costs in different area, and make sure we will provide the best services for all users. And thank you for your understanding.
I think people will also want to know what is the largest part. Our machine is the desktop level milling machine.
Right.
So what's the largest part that
the building volume will be 230 times 10 times 150 millimeter. So you can also check out the spec on our website very soon. Okay. Can you roll down for me? Yeah. Okay. How much does shipping cost? Does cost including import tariff? Yep, we just answered that question. So the shipping cost is well, we will take about 200 to 250 US dollar, and our estimation is the user probably will have to pay around 100 to 150 max, considering the overall shipping cost could reach to 400 US dollar max. Okay.
operating system. So our C500 is run on GRBL, so it's really standard that you can work with your own CAM software. Like currently, we're compatible with UG, any other CAM software, Fusion 360, and MasterCam, that you can generate the G code, and then you can just input in our software, and we can run on it. If it's not compatible, we will provide the file that is the post-processing file that you can import to your CAM software and generate a G code specific to our machine.
Okay.
So I think the machine should be ready.
Okay, now let's conduct some demonstration. So the schedule today is we will first given a short demonstration. We're not actually starting the work yet because they're gonna take 40 minutes. We don't want everybody waiting in front of the camera for the works. What we will do is we will first show the most fundamental function. We will show you how the RFID readers works. We will change the bits for a little bit, do tuning, calibration, and show the three-dimensional probe under the camera, how we do the probing. And then we will get back to my parts. We will tell you a little bit story about our background, about this machine, and we can have a Q&A section. After that, we'll conduct a 40 minutes to an hour long live demonstration of one stainless can openers processor. Okay. All right. So please show us the machine.
Please. Can't wait.
Okay, give us a second. We were changing the camera.
Can everybody sees it? Okay, can everybody see it? Can you hear me? Hello.
Oh, we can see you well. I can see you.
Okay. So as everybody sees, this is a desktop level. This is our product. It's called NestWorks C500. So this is a desktop level milling machine. So you can see I'm standing right here. It's just a really printer sized. So When you open it, it's actually a milling machine. Okay, we're gonna have a really quick demonstration for our tool changing, and also we will have our 3D prop lower down and then to center the object for you. We will have this demonstration.
对，可能是微宣它有点波动，所以不能我
Okay, so I think we can start it.
收集麦。
Please, we can. So first, as you can see, this is our toolbox. You can store 5 bits inside this toolbox. So it will automatically change the tool based on your programming, your G code. So currently we can demo this tool changing part. 可以跑一下。So as you can see, we also have this reader right here. Currently, it's automatically read the bit inside this toolbox. So the information will gather and then save in our system. Okay, so it's finished reading. So now we can continue to the tool changing. As you can see right now, we have 3 bits. After it taking the bit, it will adjust the Z height. Okay, so we can just change to another tool. 看把刀。So as you can see, the light right here is indicates the bit. Currently, we use the reader to read the bit. Then it can shows that how many bits in our toolbox. So we can return the tool. Okay, let me see. Can everybody see it? So maybe people were curious about why there is a fan blowing away on the toolbox. It's because that we will have a little bit cleaning first, and then we blow away the dust on top of the toolbox, and then we can open the gate and then grab one of the bits that we need. Okay, so this is our toolbox right here. So which we would just demonstrate. You can store 5 different bits inside this toolbox. So now we'll move on to the we can move on to the there is a 3D prop hit inside this tool that we use the prop. We can do automatically locate and center your material. Okay, sorry about the camera shaking. Currently, I'm manually just trying to show using my laptop. But don't worry, we will have videos, demos, all our features in our official website. And later we'll also show you the links. Don't worry. Okay, let me just put it right here so everybody can see it. Are there any questions? Hello, can everybody see it? Are you guys still there? So as you can see, this is our 3D prop. 你继续，没事。可以1分钟吧。
Can we purchase additional holder to expand the two libraries? Sorry, right now the two libraries fixed to 2 at a time. We cannot really change it. Can the work without a tool changer to have more work area? Yes, the entire tool library can be taken out, and you can take off the tool library and change the tool manually to get a larger building volume.
So as you can see, the prop is is trying to find out the Z height. So you can see the light changing right here. So next we move on to the x-axis. So when you touch it, it will record down the data. You can see the light changing. After that, we move on to the y-axis. So when you gather two data, you can calculate and find out the really center point on the material. And as you can see right here, we're using this tool to help us to stabilize the material. Okay, so that's our 3D prop. We will also have the camera installed under the tool. There's one, and the other camera for monitor, it was installed on the side of the machine, inside of the machine, so you can monitor the whole progress while you were closing down your gates. So the camera under the tool right here is help you to locate your material roughly, and then you can use the prop to doing the propping system to help you to actually find out the center point of your material. I didn't see this, what they were saying in the chat. Can you just refresh for me?
Sure.
Okay.
Yeah, here we go. We reconnected.
Actually, it's okay. We can just read the chat and see what people have the first thought on our machine. Sorry about the internet. It's really bad today. Okay, so please give us a second. We'll be back really soon.
We can start.
Okay, 1 second. Okay, you guys all hear us? One.
Yeah, sure. We are in the suite.
Okay.
Sorry guys, we're still trying to figure out the internet issue. I think the whole building's internet is kind of like went down a little bit. Okay, so I'm gonna check our chat right here. Can I manually lower two that doesn't fit the two box? Well, first you need to the size, the maximum length for the bit will not longer than 60 millimeters. So if your bit is like 40 or 50, then you can just store it in our toolbox.
Okay. Hello, everybody. It's Henry's back. Sorry, we got some technical problem with the networks, and sorry, since it's our first time on the live. Yes, thank you for all your questions. We will get back to some of the question and answers more. So I'm more concerned about the width when I say that. It's like the surfacing bits of like cutter. No, I don't think it will be a concern at all. We will conduct you more examples. Usually what we do is we create a rough cutting toolpath, and then after that, we will create another finishing path, which is smaller bits, hierarchy end, to guarantee you the better surfacings. And that is also one of the very fundamental working strategies of our team softwares when it's doing auto generations. Yes. All right, so I will next move to a very short introduction about our team because I heard that a lot of people have been asking about who we are. So like why is I actually come out of a team called NestWorks and building a CNC. After we talking with many people on the maker fairs in Bay Area, in California, and also in Tokyo, so we realized that it is a very good story to be shared, and people really appreciate to heard about that. So to keep long story short, we actually incubate by Elephant Robotics. Me personally, I'm also the vice president of Elephant. In the past 9 years, in Elephant, we've built many different kind of robots. We're actually one of the top desktop robotics arm suppliers in the world. So most of the university research lab were all our clients. Our market has actually reached over 40 countries in the world. So these 8 products on the screen I'm showing right now were the projects that I've been working in the past, including different type and different shape of robotics arms, AGVs, and also we have some very cute companion robots, robotic cats. So our team are mostly engineers, experts who were in hardware. They were mechanical engineers, they were electrical engineers, but we also have 2 very specific CAM software specialists. They have been working on CAM on 3D BIOS analysis for years. They were now taking heavy loads on our software development team. And other than that, we also have 2 mechanists who have been working in front of an industrial CNC of years. And so they will bring their experience on the professional CNC into our team as well. So the reason why we brought it up is we want you to know that the reason why we're building for this machine, the very beginning driven power is actually we were building a machine for ourselves. Because you probably know that hardware company like us making robotics arms or these kind of companion robots is not easy to get into mass production just in one shot. So many times we will have, because in Elephant we will publish over 10 new products each year, and it's not every product that goes to mass production, and some of them just get canceled in the middle. And that brings us to a very realistic problem, is that between prototyping and mass production, we will have a very embarrassing phase. It's called small manufacturing, that we're making only 50 robots or hundreds robots in 3 months. So those small volume creates much difficulty in terms of cost manufacturing time. So we were thinking, or whether we were able to make something for ourselves, so we can build a robot by ourselves. And that's how the story started. Now today we are very familiar with 3D printing. 3D printing is a very important change for the most hardware development team and makers. It's easy, it's fast, and the cost is extremely low compared with traditional prototyping ways. But most importantly, it's about the low learning curves. Right? Most of all of our mechanical engineers can have their design finished in the day and let the machine print it out at night, so we can get the new prototype by the next morning. And those were something that we cannot imagine in the past. And so because of that reason, right now we've owned over 10 bamboos in our company, and we enjoy the efficiency that 3D printing has brought to us. And then also similar to laser cutter and other tools that really empowers us as a small robotic company. But when we talking about metal processing is another story, right? So today we were able to get most of our plastic parts finished with 3D printers, but some of the structural parts that is taking the weights or have the strength requirements is required to be done by metal. So that is something really troubling us. In the users letter that have shares in our users group, we have been spending over $100,000 every month only by outsourcing those metal mechanical parts processing, and that gives us very very high cost in three ways. One is in financial way, costs a lot of money. And second is about the lead time. Right, every time there will be a 2 to 4 weeks lead times, and we have to wait for the suppliers to take our order, to look at our files, to generate the design for us. But also the uncertainty included in here, because we cannot guarantee they always get the work done in one try, right? So if after 2 or 3 weeks waiting, we get a part and somehow this wrong, we have to do that again. So it's very, very frustrating. And during the time waiting, sometimes your engineer get nothing to do, right? So yeah, and we also have lookup. For example, this is one of the mechanical parts in our robot's leg. It's a connection legs joint. We have tried to get a quote from Sometry. They were standard price made in USA is $319. And the problem with that is you are paying $300, not including the shipping cost, and there will be 5 business day, means a week in between, not including shipping. And the biggest problem is you cannot always guarantee your intellectual property will be protected during this processing. So it's not cheap, it's not fast, and it's not safe. So we were thinking, well, why can we have something like 3D printer? And the first question is, why can't we have a CNC for ourselves? That's actually our first try. We have very seriously studied the question. We even ready to buy a CNC machine for ourselves and try to do that all of those work in our office. But when we really look into those problems, when we're already ready to pay for the machine, and then we realize that the problem is not that easy. It's not about owning a bigger industrial CNC. The CNC is what I summarize as mechanists and programmers, which means every time when you're owning the real cost is the cost of the machine plus the salary of those 2 people, because no one able to run the machine in our teams right now. I mean, not right now, I mean 18 months ago. Our their parts on SolidWorks, they cannot generate G code out of that. And have very little knowledge about G code, about ML, about how to generate toolpath, about the working parameter. Were not easy to study, right? So we further break down of what actually were those 2 people doing. So for the mechanist, he's the one working in front of the machine and get it run. It clamping to the right position, make sure is clamped, is secured, and this mechanism will find the center point and do the 0, and it will install the tool, found the right tools, calibrates the tools, changing the tools in the middle, and after you're changing the route, do the recalibrations. And those were some tasks they have been doing. And second, the programmers, which we thought is even more difficult, is the CAM software programming. They generate, they convert the 3D files into G codes, and then they will write handmill for each works, set up the right working parameter for this very particular processing. And many of these processes needs many years of experience, right? Well, just for example, the working parameter, how fast are we running the spindle? What's the right feed? Not like a right or wrong answer. Sometimes you just need
first, many years of experience, and second, it will requires you to be very familiar with the tool you have been working on, with the mail you have been using. So along the time, you'll build up like a small data basis for yourself. So those were not easy. And when we realize that, we will first have the idea that probably we can try to build a CNC for ourselves. The goal is very easy, that we want a machine for ourselves that can make our mechanical. More importantly, it was able to used by our mechanical engineers without hiring any mechanists and programmers, just like using a 3D printers. So that's our very initial ideas. So following the logic and the concept, for the first time build up our team for this machine. That's happened in the end of 23, almost 2 years ago. And is our NestWorks C500. Yeah, so please let's allow me to show the very beautiful pictures that we have been to. This is a desktop CNC with over 200-pound net weight, 2mm accuracy. The biggest feature for this machine is, first, we have a built-in coolant system that allow us to process much harder metals, like many of you have been asking, right? Stainless, titaniums, those heavy metals, just giant processing. So coolants become very necessary. And more important is about the CAM software. We see that as the true barriers that stop most of the people get into this machine and get their hands on. Audios keep dropping in and out. I will. Okay, I hope you can hear me clear now.
Sorry guys, if you cannot see or hear us, you can just send in the group chat anytime, so we will know. So it's a little bit laggy right here, but we can saw your chat, but we can see your chat clearly. Sorry for interrupt.
Yes. So first, unlike most of the desktop machine, this is a serious industrial level spindle. It is 800 watts with max RPM of 18,000. This gives us enough power to process most of the common materials that we have seen today. Like we said, we were able to process stainless. Actually, we will run a stainless processing demonstration just after this.
Yes.
And 18,000 RPM is also important, that give us very good surface finishing. And so you want high spindle speeds to give you good finishing, just like polishing. And second, that is our very innovative RFID queue management. A lot of people have not understanding these concepts in the beginning, so I will explain this for a little bit. So in the end of each end mail we have been using, we have built in a chips for these bits, and in this bits it stores all information about the end mail you have been using. How long is this end mail? What material they've been made? What's the diameter? What type of end mail you have been using? And why is it important? Because in our CAM software, we want to auto-generate the best working parameter for you. And then in order to do that, we need to know two informations. One is what end mail we've been using in this work, and second is what materials we've been processing this time. So by having those two informations, we were able to come out of the best working parameter suggest to you, including the spindle speeds, the feed rate, the cutting depth, right? So this chips provides the information to our system. And even more important is after each work has been done, after this endmail been returned to the library, we will return the information back to our chips. So we will able to keep the working history of each endmail keep in track. Because during our processing in the beginning, we realized something that we were using exactly same parameter, same endmail, and same materials working in the same projects, but they don't always come out the same. And after we're testing many times, we realized, okay, sometimes it's because we are using a really old email, and then they brought us very bad services. And I think this tool management system will dramatically increase the performance on that. Does that mean that we have to buy tools from NestWorks? No. Very important question. Very important. We will provide official email that have the chips built in and the information written previously, but we were supporting all third parties email as long as they were standard ER11 bits. You can easily use it in our tool library, and we will also provide empty chips that you can use to write in the information manually. You can also have the features run on the machine without the official bits out. So they were all doable. What is the QR code on the material used for? Yes, the QR code, you remember I just said, in order to suggest the best working parameter, we need two information. One is the endmail, one is the materials. And then the QR code is used to store the information about the materials, and also it will be provide from NestWorks official, but as I have said, you can also use any third-party materials. Okay, that's about the RFID. And then we also provide very fundamental automatic tool changing features with a built-in calibrators. After each bit has been put up, we always calibrate the tools before the work taking place. Roughly how much more expensive is the clear email than the dump version? I think they were the same. Visual aid and light, that is very important. Another features that we heard very positive feedback from our users. We have one camera and one LiDAR sensor being installed under the spindle. They were used to assist you to first locate the position of the material that is building, and second, they help us to do the edge founding and detect any strange objects in the working platform to avoid crushing the spindle. And after we have found the materials, we have located the position, we will go to our auto probing, and that's also the feature we just been showing. We have built in a very high accuracy touching probe that will save you a huge amount of time by doing the probe manually, and also that secure the accuracy of the probing, especially when you were doing multiple sites metal processing. It's very important to find the accurate 0 point to start with. Otherwise, well, we don't always keep like both sides alignment once we flip, right? This was some problem that will often occur. And during the demonstration later, we will also show you how we get it done by combining the 3D probe and the camera assist system. And then, of course, we also provide more basic function like auto leveling. Especially they will be crucial, especially when you are working with PCB or other flat platforms, or you want to cut a on flat surfaces. And the last part is about our CAM softwares. Like we have been said before, this CAM software aims to get all work done in 3 clicks. So first click is we quick generator. Yes, the main goal of this CAM software is to get work done in 3 clicks. So first in our software, it will auto recognize what the materials you have been building and the size of the materials we have installed. If you bought from the NestWorks official, it will done automatically. If not, you can also put it manually. And second, you simply port in any 2D or 3D files. And third is that we will generate the 2 paths based on the end mills we have been using and based on the materials you have been installed. And then we will create the 2 paths for you just in 1 click. And the second click is you click the auto probing. We will found the edge, we will found the center point, and that will give you the starting points of this works. And then the third click is simply to start and run the programs. And the tools and coolants management, they will all visualize almost like playing a video games, that you will able to see what end mill you have been using, what type of coolant that we have been installed into coolant tank. In some cases, you can even store 2 type of coolants in 2 tanks simultaneously. Right now, we were supporting 2D and 3D files analysis, including SVG, STL, STP, STEP files. All of those formats will be supported in our CAM software. And after you have built in the materials and the model, we will automatically suggest the working strategy for you. And just to keep it clear, everything we generate and everything we suggest that is also available for you to change manually. So our system will suggest the end mill for you to use on your roughing and on your finishing, but you can also change it to another bits. For the parameter, you can also change them manually. Those were all open to our users. And then we will have the 2 paths been generated, and you can also have a preview before you actually get into works. The next feature is about coolants. Right now, we do not have a built-in air compressor. Many people have been asking. So by using the coolants, the mist coolant is required you to have a external compressor connect to our machines. And also, yes, like you have been asking, the liquids, the coolants right now would just being collects on the drawer. So the volume is not high, I have to admit, and we do not have a recycling system based on the size and the volume of this desktop machine. But if you want to do the recycling of coolant, or you want to do flat coolant, we might introduce a bigger like industrial recycling kits by 2026. So they will have a pump included. But before that, I think you can also easily build in your own recycling system, whether it's connect to a bigger coolant tank or is connect to a recycling pump. Those could also be done by the user. Yes, when I'm saying the NestWorks CAM, It doesn't mean that it's required to use. We support third-party software like Fusion and Mastercam. We will have our post-processor being shared for other third-party platform as well.
Could you tell me like what cam software are you currently using on? We can just type in the group chat so we can know.
Yep. Is the cutting fluid environmental friendly? It depends on what's the fluid you have been using. Right now, we were using most of water-based coolants for aluminum and titanium work because those two were more tricky. But we also know some users are using coolant oils. Those could be a little bit rougher. But yeah, it's only depending on what coolant you've been using.
Yes, GRBL.
Right. Now and in here we were sharing some of the working examples. We were cutting in the left side is 6061 aluminum, and the right side will be a cardboard PCB board. And also because this is a desktop level CNC, we believe that many times people will be using in their garage or in their studio or even just in-house. So we pay many times and efforts on trying to make this machine easier to use, better industrial design, make it more elegant, more even like a workpiece you can put in the house. But also we really try to have a clean and safe working CNC at home, which is very difficult. So we have a ear assisted self-cleaning inside, like I explained it in the beginning. We have two built-in fans, so even you are not connecting to an air compressor, you can also use our fan to clean the table, to cool down the end mount. But also you were able to connect to a vacuum to take away the dry chips. The wet chips could be a bit challenging. Well, our suggestion is to use the high pressure air to clean the wet chips on the working table. But in any ways, you can always have all the chips being collected on our bottom drawer. The experience on that is very good. And also, we provide many accessories to help you achieve better experience, including our force axis and our electrical lights. I think I have so many questions related to our force axis. I think I should post more about our force axis after the live today. Keep it simple is because we are a robotic company, so we are very familiar with harmonic drive and brushless motors. This force axis is using robotic level harmonic drive and a step NEMA 23 step motor. So the torque point is high and the accuracy is very high. The maximum walking volume is 110 in diameter, and the overall length I think is 80 millimeter. Allow me to double check it.
People were asking about how much with the 4-axis and when will it be released.
The price of the accessory have not been finally confirmed yet. We will keep you posted, but definitely the price will be confirmed when it starts to get online. Right now, we were thinking around $500 because the harmonic drive is not cheap, and the motor is not cheap either. So we will try to see how much we can do on manufacturing side to bring the cost down. But it will around $500-600 just for now, and also for the electrical lights. Yeah, and yeah, we were doing our parts to bring the cost down. The machine is running from 100 to 230 watts adaptive, which means that you don't have to change your power grids. It will fit in most of the standard outlets. How big is the part? Yeah, it will be a 110 diameter with a maximum length of 80 millimeter. And last but not the least, we also provide a small laser engraver. To be honest, it's just a 5 watts laser, nothing exciting. Because if you cut anything, you use the end mill. The laser is used to help you do a little engraving, like mark a logo, mark the spec on the PCB boards. It's a good helper. And for some users who are very experienced on CNC, they love to use their hand wheel. We also provide that. I personally love that. It's very accurate, and the experience is great. Does it come with a EU plug? Yes, yes. Yeah, so after I've introduced all the features and some very innovative function, let's review to those two persons' work. We I have been kept telling my team and also our users that we have a very fundamental philosophy is that all hardware is designed for software, right? Why we want to have an ATC inside, why we have a 3D probe inside, that all serve to the very end goal that we want our user to able to use our machine in only three click, and that brings back the logic. In order to allow that happen, we need to have those functions. We need to have a automatic tool changers, so you don't have to change tool manually. We're required to have some sort of math to help you do the probing, whether it's assisted by camera or not. So our user don't have to do the probing manually, and we have to have a CAM software that generates the toolpaths for our users, so we don't have to learn those very difficult software. And that's our very, very fundamental logic, how we design this machine, why the machine has been built in this way, why is the footprints in this size not any larger or any smaller. That was all based on this very one goal, right? Well, we want all users able to use CNC to bring their design into a physical object in real world without too much of difficult learning curves. Yes. Yes, I can confirm to you that the working parameter is 230 times 210 times 130. Yeah, 213 or 128 is more accurate number. Yes. Apologize for me. Sometimes just rounding the numbers. All right. So that's will be our specification for this machine. Like many people ask, it runs on one. Oh, sorry, I didn't update this. It's actually one on 110 to 230 watts input adaptive. And machine was built with ball screw with a lead of 5 millimeter, and we're using dual line rails instead of one, and using all three NEMA 103 closed loop stepper to secure our accuracy. Does this cooling system needs to be used with the air compressor? Yes, since we are using a mist coolant, so it will require you to have a air compressor. And right now, the retail price for this machine will be around 5,000 US dollar. But because now we are running a Kickstarter campaign, so it's only one time we'll offer $25.99. This very, very early VIP prices. If you place a deposit today. Otherwise, I think the early price on Kickstarter will be $27.99, $200 more. And we will not ever have these kind of lower price in history ever. And today we have been working with University of California, Berkeley. We have donate one machine in the Jacob Institute. So if you live nearby Bay areas, you can probably just go check out with Jacob, send an email, see if you can go pay a visit and try a machine on hand. And in Japan, we also donate one machine to University of Kanazawa. So if you are a Japanese user, or you live near Kanazawa, you can also try to pay a visit to their labs The reason why we were doing the cooperation with the campus is we still understand in this very early R&D phases, we're still facing many problems. So we want to have more engineer students using our machine, give us feedback so we can work with them to have a better machine for you together. Yes, there are encoder included in our step motor. That's why they were closed loop. There are encoder included. The deposit right now you can place is $30, and they were fully refundable. Once the Kickstarter ends up, this $30 will be refunded to your account. Yes. If you place the deposit, it's not just secure the lowest price of $25.99, but also the shipping time that we will first patch. Right now, we are aiming a monthly productivity of around 1,000 units of this machine. So if you will place the deposit as the first 1,000, we were confident we can deliver the product no later than June 2026. But if not, it might wait another month or another 2 months after. Yeah, because we cannot have all 3,000 or 5,000 units produced in 1 month. It's not easy. Yeah, please understand. And thank you for your support. If you have already placed your order. All right. So that's very much that is very much all we got to share for our story and background, why we are making this machine. So please let us know if you have any questions. We can answer for you. And also, we will get into our Q&A sections. We have previously collected some questions from our users, and also yes, from our users, and also you are welcome to ask any question you might have.
I think some of the people just joined. They are really curious about the laser sensor. What type of laser sensor is
that? The laser purpose is that, let me try to explain. Because we have a camera assist to find the position and the location of the material. But in some case, we saw that people not just using like the official clamp that we provide, they will use their own long screw to clamp the materials. Some of them is very long, like 3 inches long. And in those scenarios, our cameras in the top can see nothing, right? It's like a dot under the camera. So on those scenarios, it's possible that during the probing, our spindle could crash with the screw or another object that you have to install. And the purpose for us to install a laser inside is to plan the height of the material we have been building. So we were able to build in a pretty quick 3D model. It's mostly it's a point cloud. So we were able, the machine were able to detect whether there's strange objects getting related to our working platform, so we can avoid a potential collision from happening. Does the machine have a vacuum attachment? Yes, we have a vacuum attachment, and we will also provide the nozzle connector we'll try to fit in most of the most common vacuum that you have seen on the markets. How many camera angles do you have? Can you show me the camera footage? Yes, we'll show you the camera footage once we move on to the software demonstration later. But we will have 2 cameras. One on the top of the spindle, help to find the position, help to do the probing, And the second will be on the side for the monitoring purposes, so you can monitor your working situations on your phone. For the accessory optional price will be posted by the first day of Kickstarter, which I think is 2 weeks from now. Sorry for waiting a little bit. Sorry that we have not been built up on our Discord yet, but you're welcome to join our Facebook groups by finding the link under the YouTube description. You will find a link now.
How many camera angles do we
I
have?
think we just answered that. Yep. So that's. I think we have already answered most of the questions that the user could like previously. Do we get anything missed?
I have one question.
Mhm.
That is, what is the torque spec on the auto cushion?
What is the torque? Let me double check that number with my testing team, or we have one, but I cannot guarantee the number in my mind is right. So let me post that later.
Still, I saw some of the comments that talk about the 4-axis. People are really curious about the 4-axis.
Can we get a full demo? Yes, we will run a full demo just right after. We will run a 14 minutes long stainless piece work. So please wait for that.
We'll also show you after done
Yeah. So we're making a can opener here, so I will be made out of, I think it's 304 stainless. Am I correct? Yes. Yeah. It's a 304 stainless where we're working today. Will you have local warehouse accessories or replacement parts? It depends where you are. We will have partners in certain countries and areas, but some of the countries might not. So we'll see. But we have been already actively contacting with many distributors. We will many great potential partners also now in discussion with us. And there's also our goal to have great local supporters for after sales services implementing. No. The demonstration will be held today. So we'll be right after this Q&A session. I believe we will start in 20 minutes. So please wait for that.
But we'll continue to post the video of our doing an object in the website. So
yes. So also please follow our social media platforms in YouTube and Facebook. We'll keep our case video posts every week. Actually, every day right now. Yeah. We are already working with copper, with aluminum, with stainless. We were currently running the videos on titanium. So we'll keep that process. And please follow us.
I also have a question about, like, the people are asking about, will the software be friendly enough for someone with zero card experience to learn?
Yes, please tell me your answer once I have shown you the demonstration after this.
Yeah, you can also write down any of your suggestions in the comments. We are really welcome any suggestions.
Will you have a 5-axis machine in the future? That is a very difficult question. I think we all want to do it, but we have to admit that at this point it's still a bit early. It's not about hardware, but mostly about the software, right? Because from 3-axis to 5-axis, the difficulty of the CAM software, especially when we want to do auto 2 fast generation, the amount of difficulty is running.
Our plan is actually want to go step by step.
Right. We want to provide a very stable and reliable 3-axis software, and we will, but we will definitely work on 5-axis. I think that's something we will be delivered eventually. Yeah. All right. I think we have already answered most of the questions I saw on the list and comment. if we didn't miss anything, I think people just want us to move on to the actual demonstration parts, right? Talk less, do more. For stimulus efficiency, yes, like I've been saying in the beginning that we were actually designing this machine for ourselves for all our mechanical engineers. We want our engineer able to use this machine for themselves, because today they were able to run almost all 3D printers by themselves. They can have their design being demonstrated in only a few hours. It's very common in our office. You see people finish their design in the morning and then they send it to the printers and get their work piece by the next day. But we have to wait long times for our metal parts, and then they really slow down our development. So our initial goal is to design a machine for ourselves. So of course, if we can help ourselves on that, we are more confident we can help you. And the reason why I don't call it a CNC for beginner, it means that when we say beginner or hobbyist, people usually assume that we're working with wood, with lower accuracy. But in our case, since we're making robots, we actually have requirements on the mechanical parts. Otherwise, we cannot have the robot runs. And second is that we almost never done wood piece working in our office. We only work with metal parts. Aluminum's most common. Carbon fiber sometimes. Those two were the most common materials that we have been using for ourselves. And that is also the first. That's the piece that I've been showing on my keynotes. Is a 6061 aluminum piece. It's actually a connection joint on a bipedal robot's leg on our open duct robot. So all of these pieces we've been showing today were the actual robotic parts that's running in our product today. So it's not like just come out with some random example. You can also show me that piece. Yep. Like this is a connection joint on our robotic arms. It's a structural part. It's supporting our joints. So those were something that we were working every day. And that's also another good part that I think is good for our team making a CNC is that because we are the user, right? So we were able to provide very objective opinions and comments to this machine. If this machine cannot get my robotic part done, then it's failed. And let's keep improving that until I can get my part done. Okay. What size compressor is needed? Not very big. I understand that most of the time people don't have a very big compressor at home. So our suggestion is don't get something bigger than 0.3 MPa. Get something bigger than 0.3. It will be sufficient. If you have something bigger than that, it will be even better. Can you share details about tapping supports? Will it support rigid tapping directly through this window? Yes, we can do tapping. I will show you in our software demonstration really soon. But keep in mind, tapping and drilling a hole requires much precise controlling. So we have to take those two functions as a separate module in our software that I can show you later. And you will require specific tapping ML to do it. The air compressor and MQO optional. How much they cost? So the overall MQO system is already built in this machine. They were standard. So all the air tubes, all the pump system were already inside the machine. They were standard machine. It's not optional. You just pay for the standard price and you get it. But it's optional for you to use an air compressor. If you don't have one, you don't want to use it, it's fine. Yeah, but the cost is probably you cannot use the miscoolant. Yes, many people are asking about air compressor. Yes, you will require to buy a air compressor, but we might also introduce a compressor from official sites. we might not conclusion yet. Can it handle material larger than the build volume? Sorry, currently not, since we were a fully enclosure machine, so we cannot go over the building volume. But what you can do is you have the option to take off the changing magazine. So it will give you a larger volume. I think it goes all the way to 320 on the X basis. So 100 larger than the current size. Yeah, so it's free to have a compressor. All right, so I think we were able to get into the demonstration part. Okay, so let's please help me set up the software first, so we can go through the software demonstration for our user first. Okay, so let me know if you can see our software. You can see my screen clear. I have a little legacy. Wait.
Yeah, if you guys have any more questions, then you can just feel free to type in the chat.
Okay, so just give a quick introduction of the softwares. So we have separates this our studio to field function. Because right now, keep in mind, it's still a beta testing version, so it's not on the cloud yet. In the futures, in our community, everybody can share their designs and files on our community. So you can help each other on the design or use others' working files. And on the device, you're able to see the machine situation. We were able to control the device manually to do the offsets, to change the bits manually, to do the X, Y, and Z control. If we have the work going on here, we can also track the working situation, and also we were able to manage our tools and coolant in here. If you have the end mill with the RFID chips, so the machine will automatically read the bits information, and you are able to see it. If not, you can also update your tool manually. There's a lot of people ask, right? So if you have bought your end mill from any third-party suppliers, then you can install the empty RFID chips and then build in manually. Have to use the coolant, but if you do, you're able to set up a coolant situation in here. And also we provide calibrations options for you. All right, so I will now just get into our work today. Because we do not have the official RFID QR code label materials being used today, so I will have to set up the materials in hand, right? So what's the diameter of the object you're using today? Can you please what's the diameter? What's the size? Okay. So we can first just put in the number because I don't have a in my material list yet, so we will just use maybe a carbon fiber for now. But I will change the parameter manually. we can build in the materials. And you can see now we got a 3mm thick stainless been built in here. And the second part is that let's go to model. We can simply import any 2D or 3D files for our CAM software to analysis. But if you already have your G codes from a third-party CAM software, you can also import your G code directly. But in this case, we have a 3D files, so I will put in a STL file here. Okay, so you can see now I have my materials building. I have my can openers files in here. You're able to check it out. In order to save the materials, we always want to keep the top surfaces of the working objects alignment to the material, right? So I will do alignments. And if you've built bigger volume than that, you can also do it. If you want to change the size you have been working this time, you can also easily change it on our CAM software. I think we want to run it the top surface space. And then goes to our most important function, is what we call the smart mailing in one click. We simply click and it will see what's the end mail we've been using and what's the coolant we've been using today, and the working parameters suggested. And more importantly, sometimes we will need support to do it. Our systems will even automatically suggest you the number of supports or you call and the position of it. Sorry, it's a bit slow. Oh, seems like the support for this one is not being shown. I will come back to that. But like you said, all the parameters you set in here, you can change manually. Like you see, I've only clicked one click in the two pass generation. I've done nothing yet, simply checking the parameter, right? And then we can just go click the create two path. Okay, you can see a two pass have been created in the script line, but we can definitely check in with three-dimensional preview. Zoom in for a little bit. It shows you how many tools you have been using. Like today, we used to carving the words in the surfaces of this can opener. We will use a second tool, but for this workpiece, we are only using one tool. So you can see on the right side, it's also using tool 4. So we were not using a second tools. So in this point, you can either load in this to this file to our machine, or we can also export the G codes and run even on a second CNC, and it will work. Oh, I see. Because my CAM software has not been connected to the machine yet. That's why it's not given a very accuracy number. Right. It's okay. We can connect later. I just want to show people how it works. We might have to connect it to a second computer, but I think it's easier for demonstration. Yeah.
People were asking about, can the software run offline or does it run cloud-based?
For the generation parts, for the two-path generation parts, we recommend you to run cloud-based because it's faster. But once you have the G code, it will run offline. Mm-hmm.
You can also use a thumb drive to copy your code, plug in on the machine, and then just directly run it.
1 second, guys. We're switching to another laptop so we can show the software more clear. Will I be able to save the past my computer and use the same tool? Yes, you can just simply just export your G code as an NC file. You can use it anytime in the future.
So nc.g code file.
Yes, you can generate the two-pass offline. Just taking when you were generating the two-pass offline, that means you are using the computing powers of the laptops or your own PC. It will be slower than do it on the cloud, but those were all optional.
要不先让那个机器连这边的就这个网站那个网络，直播就可以，会，就让机器跟这个合类。
对。Anyway，
这个密码。那现在跟这个连上了，一起加工的，加工室，那这还可以打。
Okay.
Yeah, your PC is strong.
Hello. Can you hear us again? Sorry. I think we have been disconnected for a while. Can you guys hear us right now?
Hello, guys. Can you hear me?
Can you hear us?
Yes, they say hello.
Okay. Sorry. We try to switch the networks so we can connect to our machine wirelessly, and then I think that creates some mistake in the process. Sorry.
So to answer the question, we are currently in China, Shenzhen. So yes, just like I said, I don't know. I think we are back.
Okay. Please let me know you can hear my voice well. You can see our software platform well. We are getting started for our work demonstration. Okay. Thank you. All right. Sorry for being a little bit dry in here. Sorry. I apologize. It's first time for my team to conduct a live event like this. I'm not very happy with whatever performance we got today. We'll definitely get improved for the second time. Okay. So I just take some time to switch the networks. So this machine can connect to our laptops wirelessly as long as they're staying under the same Wi-Fi environments. So now we were able to do what we call in here is the table scan. Means we cannot see the machine at the same time. We were using the LiDAR to scan the objects under it and create a three-dimensional cloud point. So you can see that we are now creating the 3D model for our magazine with the automatic tool changer library. And then let me show you the auto probing. And because we like I've introduced, that we have a camera under the spindle. So when we're doing probing, we can simply use our camera to help you locate the material position. How it works is that we can manually select what's the area we want to do the probing. So once I've been selected, I can simply use my mouse to select the area that we want the 3D probe to conduct the work. Once I've finished this part, I simply go auto centering. Okay, and please show the probing to our user. One second. While we are using the camera. So we're now doing the probing. You can see now the 3D probe is probing the area that we just selected. Okay, now we've already have the 0 offsets ready, and we are about to start the work. I just want to remind you again, we are working with a 304 stainless 3mm thick today, making a can opener. So this process will take about 30 to 40 minutes long, and we will not stop during this process. We're now picking up the first tool we've been using today.